Hi, this is Antonio Mejorado, and this tutorial is to understand how to use a function with more complex decisions. Decisions that are more complex because it's not that easy, so you have to use like more logical operators, not and, or they involve more than only one if, or a combination of different kind of ifs, independent ifs or nested ifs, which means an if inside of another if, or something like that. So sometimes you need to think very carefully before writing the code for the solution. Here you have an example, the quadrants example. Based on a coordinate and a point x, y, the function must calculate the quadrant number. So we have from 1 to 4 quadrants. Quadrant number 1 is for x positive and y positive. Quadrant number 2 is for x positive and y negative. Okay. Quadrant number 3 is for x negative and y negative. And quadrant number 4 is for x negative and y positive. So we have to write a function that needs ifs. Here you have the solution. We have two parameters, the x and the y, and the first if is to get if the x and the y both are bigger than 0. If that is true, then we have the quadrant equals number 1, which is the function name. Otherwise, we check if the x is bigger than 0 and y is less than 0. In that case, both should be true. The quadrant is number 2. If the first one was false and the second one was false, well, the third one is to check for x less than 0 and y less than 0. So we're using the quadrant number 3 as a result. So the last one is for x less than 0 and y bigger than 0. So we're talking about the quadrant number 4. Okay. Well, we can try that on our worksheet with different values for x and y. So you will see that if x is positive and y is positive, then we have the quadrant number 1. Quadrant number 2 will be for x positive, y negative, and so on. So we have 4 different quadrant numbers because we're using all this combination of the x and y. What about if our x or y are 0? Well, in that case we have the quadrant as 0 because there is no assignment to the quadrant number to our quadrant function in that case, okay, because that's the way it works in Visual Basic for Excel. But we have to write that, we have to be more explicit in that solution. So it's better to have another else if and having that condition for x equals 0 or y equals 0. In both cases, it doesn't matter if it's x 0 or y 0, we have to assign the quadrant to 0. That is better because it's more explicit solution. Here you have another example, the triangle example. We have the type of triangle depending on the length of the sides of the triangle. If we have 3 equal sides, we have the equilateral triangle. If we have 2 equal sides, we have the isosceles. And if we have no equal sides, then we're talking about this scaling triangle. Okay, so we have to get the length of every side, and depending on that we have to decide the type of triangle we're talking about in the function. So we're gonna have the solution will check for the equal side first to assign the equilateral. Then if that is not true, then check if we have 2 equal sides. In that case we have the isosceles, and the last option will be to check for scaling. So in the case that we have not equilateral or isosceles, then we're having the scaling triangle. So our solution is we're having 3 parameters from as the function for the side 1, the side 2, and the side 3. And the first thing we're doing is checking if we have both these 3 sides they equal. So this side 1 equals this side 2 and this side 2 equals this side 3. Then we're talking about the equilateral triangle. Otherwise, we're trying to check if two sides are equal, side 1 and side 2, or side 2 and side 3, or side 1 and side 3. In that case we have the isosceles. Otherwise, if the first one was false and the second one was false, then we have the triangle type scaling. So we don't have to have another conditional for that. So you have the solution in the worksheet having different sides, like for example the first one, we have the side 1 equal to the side 3, we have the isosceles. If the three sides are equal, then we have the equilateral, and the last one, they are different, so we have the scaling. We have another example. We're trying to write a function to calculate in or out depending on a criteria on the weight and height. If the weight is between 70 and 80 and the height is bigger than 175, then we're trying to get the in. Otherwise, we're trying to get out. So in that different values, you will see that only for these values between 70 and 80, including 70 and 80, then if the height is bigger than 175, then we're in. There you have this value, 70 with 185 is in, 75 with 185 is in, 780 with 185 is in. So that's the solution. The solution you should write by writing a function. So write a function to get in if the weight is between 70 and 80 and the height is bigger than 175 to infinite, and out will be only in other case. So try to practice this. Goodbye.